My name's Jean, and I'm with the SeaDoc Society along with Joe Gatos. Raise your hand, Joe Gatos. Yeah. Joe T. Joe T's around here somewhere. And then Laura from Camp Orkyla. And we'd like to welcome you to tonight's lecture, The History of Saving the Ocean with Gary Davis. This is our 11th year of doing the Marine Lecture Series, and it simply would not be possible without our sponsors. Tom Averna, Deer Harbor Charters, Barbara Brown, who's here this evening, Barbara Bentley, and her husband Glenn Pritchwich, Dean and Audrey Stupke, who are here too, I believe, and West Sound Marina. So if you get a chance, please thank them, because it would not be possible without their help. So for information about SeaDoc and Camp Orkyla, feel free to go onto their websites or their Facebook page. I completely forgot all the information today. So Gary, I have the distinct pleasure of working with Gary because he's the chair of our board of directors on SeaDoc. And I keep finding out all these fascinating things that you've done with your life, Gary. And you're going to find out tonight as you go through his presentation. A couple things that I'm pretty amazed about: that he's a former aquanaut, and he is chief ocean scientist for the National Park Service and former science advisory for the Channel Islands National Park. He's also the person who started the Great American Fish Count. So for those of you who are divers, you would know what that was about, and I'm sure you're going to probably tell a little bit about that. So without any further ado, Gary Davis. Thank you.
Thank you, Jean. That's a wonderful introduction, short and to the point. What a lovely, lovely rainy evening. I'm pleased to be here. I come from Southern California, where free water falling out of the sky is a cause for celebration. Right? So thanks for showing up to celebrate with me. I think it's going to be a lot of fun. As Jean said, the title of this was really supposed to be The History of Saving the Ocean, but one of the first things that came to my mind as I started to put this together was, who's saving whom? Are we saving the ocean, or is the ocean saving us? And I think that's something for us to think about this evening. We have gone to the ocean as a group, all of us, to get food and fiber and to dump our garbage. We've been using the ocean, and it's been supporting us, producing most of the oxygen in our atmosphere. It's been absorbing the carbon dioxide that we produce. Yet we've been using the ocean in lots of ways, and it's in trouble right now. I don't think there's any question about that, and the question is, what can we do about it? And that's kind of what we want to talk about a little bit tonight. Right? But I will do some history things, as promised. We will do that, but I thought history can be really dry. I love it. But all of us, when we reach a certain age, become historians, after all. And I'm kind of at that point. But I think that probably most, if not all of us, are here tonight because we have some curiosity about the ocean. We're interested in exploring. All people like to explore. It's in our genes. We're hunter-gatherers. We have to explore. From the very beginning of time, people have had to explore. They use up their resources and they explore into where can we find some more. Right? That's essential for us. And something has happened in our lifetimes that has never happened before, and that is we ran out of new places to go and new resources to use for food and shelter. Right? We need to find ways of doing business, and the ocean is part of that. And for that reason, maybe some of us are even a little concerned about the condition of the ocean. So what I want to do tonight is talk a little bit about that, about how did we get started in this idea of exploring the ocean and doing these sorts of things. I want to spend most of our time, though, in the last 60 years or so, because that's when change has really begun to occur at an increasingly rapid rate that we have seen all over the globe. And talk about how we've just now begun to understand how the ocean functions, and what it does and what it doesn't do, and what we can do to help it, and what our relationship with the ocean has been and what it might be into the future. And talk a little bit about the future at the end, things that we can do individually, collectively, to improve the health of the ocean, which is really our concern. So, it should be a lot of fun. People have gone to sea, driven largely by commerce and the security that is required by a nation state to support that commerce. So in the 15th century, people took off from Europe in ships looking for spices in the east. The British had cut down most of the trees on their little island, and they were looking for more timber for the masts of their ship to support their navy that was protecting the fleets of ships that were going out for commerce. So what was driving people to learn about the ocean was, how do we get more resources? How do we get more food? How do we get more timber for building? How do we get oil, right? How do we get energy? How do we lubricate the Industrial Revolution? And before we had petroleum, we had whales. That was kind of the beginning. And the beginning of our idea of trying to figure out how we get more out of the system. How do we improve our ability to use the ocean wisely? How do we do this? Started with whales. And so really the modern version of our exploration of the ocean, of our relationship with the ocean, and it really begins at the end of the 19th, the beginning of the 20th century. As Europeans took off into the North Atlantic, first they took whales that were right in the neighborhood. But it wasn't very long before they found they had to go further and further afield to be able to find those fish. Just like the Portuguese used to take off and go offshore before they turned north. They went far enough offshore that nobody on land could see where they went. They were going to the special fishing grounds in the North Atlantic, the Grand Banks, where they could scoop 6-foot-long cod out of the ocean with baskets. Right? They didn't want anybody to know where they were going. Well, as all of that declined, they started to move further and further around the world. The Beagle, Her Majesty's ship, the Beagle, which Charles Darwin took off in 1830 and went around the world exploring, right? Supported in large part by concerns about national security and about commerce and how we're going to deal with those kinds of issues. The Challenger expedition, also British, took off in 1853 and went around the world charting the world's oceans for the first time, really doing detailed oceanographic vessel surveys. But it wasn't until we began the early part of the 20th century and we depleted a lot of resources near home for Western Europe and North America that people began to look for other ways of doing business. So it starts with the whales. One of the challenges that they had with whales was, well, where do they go? Are the whales that you see in South Africa, all right, the same whales that you see on the southern ocean grounds near Antarctica? Or are they separate populations? Are the northern hemisphere whales different than the southern hemisphere whales? Are they the same ones? Are they moving around? How old do they get? How often do they reproduce? Just the basic biology of these animals was unknown. How do we find out about that? The Norwegians were really excited about this. They were really into whaling. That was a specialty for the nation, and they led the charge to figure out what was going on. But it was the industry that was interested in this, and they took a species approach because it was clear that some whales have big teeth and they eat meat, and there are other whales that have filters in their mouths, the baleen whales, and they filter out plankton. They eat different things, but they're really different animals. Let's take this one species at a time. And they began building information about the biology of the animals based on the individual species. And they were also interested in how much can we take out of the system? How can we take more and sustain this? We want to stay in business for a while, right? So they were interested by that. So they invited biologists to go out with them. They hired biologists to go with them. As it turns out, there were no independent evaluations of the biology, of the productivity of these populations, because all of the scientists who were engaged in this were beholden to the industry. They were living on the whaling vessels, in the processing stations on South Georgia Island. They were entrained in the system. And when the whale populations began to collapse, the scientists gave early warnings, but they couldn't yell too loud about, you know, there's a disaster ahead of you, because a lot of the business people were concerned about the short-term profits and return on their investments. And whales were not saved by conservation, by the science that was developed to understand the whales or the ocean. It was saved by petroleum, an alternative source of energy, an alternative source of lubrication. Right? So in actual fact, our first efforts to understand and sustain resources in the ocean in the modern era really didn't turn out so well. We did learn a lot of things. We made a lot of mistakes. And from that we learned, and that was definitely a benefit. Right? Things really didn't start to pick up in our understanding of the ocean until the mid-20th century. In the 1940s, when the captain and his brother-in-law developed the demand regulator that allowed people to breathe air underwater, was the first time that scientists and other people had an opportunity to explore the ocean on a personal basis, to understand what was there, to see the fish and the crabs interacting with each other, with their habitats, and with the environment. So just being able to be there made a huge difference. And that didn't start until the mid-1940s. And in fact, it really wasn't until 1957 that people really had access to the ocean, because we developed two things at that time. One was neoprene rubber, which kept people warm in cold water. And second was repetitive dive tables. Prior to 1957, if you made one dive, you were out for the day. That's all you could do, unless you did decompression and you stayed in decompression chambers. It was dangerous. Nobody could do it as a recreation. Scientists couldn't afford to do it. Only the military could really afford to do that, or heavy industry. Right? It was really hard to do. But in 1957, the US Navy, working with the British Navy, worked out a whole system of tables that said, well, if you stay this long at this time, you could do that again in an hour, or you could do that again in 90 minutes. So they worked a way that you could actually spend the whole day diving. So you could put time in. That opened the doors to exploration on a personal basis for scientists. And it turns out I began diving in 1957. I thought that was normal. Everybody does this all the time, right? It was only much later that I learned how lucky I was. So what I propose to do for the rest of our time this evening is kind of take you on a Forrest Gump journey through my time in the ocean, which has been from the 1950s till last week, or tomorrow. We're all lucky. And just kind of take you through some of the highlights, some of the things that we've learned along the way that I think will help us understand where we are today and how we might find a way forward, how we might find a way to improve our relationship with the ocean and our outlooks. I just happened to be at the right places at the right time, as Jean was suggesting. And I thought I would share some of that with you and talk a little bit about what we might learn from that would make it interesting. My explorations with nature, let alone the ocean, began in the tide pools of Southern California along the coast of San Diego. And there I was able, without any adult supervision, to run safely through nature and explore really wild places and find bizarre life forms. I mean, you remember that bar scene in Star Wars with all those creatures? It's nothing compared to what you find in any tide pool, right? All the phyla, all the different kinds of plants and animals. And as a small person, I could run around and explore all of that and discover things on my own. It was my initiative. I could invent better ways to look for and to capture these things and to try to figure out what they were. And I didn't realize it at the time, but all the adventures I was having in the tide pools were pre-adapting me for a career in science, because that's really all scientists do, right? We go out and explore, discover, have adventures, invent things, right? That's what science is about. And I loved it, and I still do. But the tide pools were a great place to start that. And in fact, these particular tide pools are in a national park, and they are still there today. And children are still learning the same things. They have the same opportunities because of the protection afforded to those tide pools. Really an interesting lesson and a concept. Right? Well, after many years of playing in the tide pools and on the beach, learning to dive in the 1950s, I took jobs in the summertime, school breaks, working as a deckhand on commercial and sport fishing boats in San Diego. And we would go out in the mornings. First thing, we'd leave the dock at 2 or 2:30 in the morning. We'd go out and we'd catch little Pacific mackerel, 8 to 12 inches long, and we'd use that for bait to catch yellowtail and tuna and marlin. And we took sport fishermen out with us as well, charter boats, and we would take them out to go fishing, and every day we'd come back and we would report to the newspaper, like a box score, how many of these different kinds of big game fish that we caught. And all of the boats would do that, so we were kind of in competition with each other. People would read the newspapers and decide who to go fishing with. Right? So it was a great way to keep track of things. But it also turned out that I started fishing in 1957, same time I started diving. And in 1957, 1958, 1959, we had warm water all up and down the Pacific coast. And we had tropical fish. We had lots of these big yellowtail, these big jacks. And they get to 100 pounds, but the 30 and 40 pound fish were not uncommon. The marlin were up. And then in 1960, it all changed. They didn't show up when it came time to go fishing. But further offshore, we had albacore and bluefin tuna. The whole ocean had changed after those 3 years. And I thought, well, the first 3 years that I was fishing, that established my baseline. That's what's normal. It was my first experience with it. Why has it changed? What is this all about? Well, it turned out that what had changed was 57, 8, and 9 were one of the largest El Nino events in recorded history. El Nino is this swash of warm water that comes up onto the Americas. It's a high-pressure area that sets up off of Southeast Asia, pushes down on the ocean, it sloshes up on the other side, and you get warm water going north and south along the coast. Right? That wasn't normal. It was normal, but it was a variation. The world wasn't running on averages. It ran on extremes. And that was something that I had to learn. But I didn't know that at the time, so that sent me running off to the University for Training in Fisheries Science. One, how do we better engineer the environment to get more out of the fish? What's the best management strategy for fishery stocks? We wanted to develop those things. I wanted to learn that science. And the other thing is that I was introduced at university to a brand new, just an emerging science called ecology, the study of organisms and their environments. And I discovered that national parks were more than just great places to go on camping vacations with the family. They were wonderful laboratories for studying nature, for understanding how whole systems work, how these organisms relate to their environment, and how we could better understand that. I thought, well, this is really exciting. So I became a park ranger at Lassen Volcanic National Park in Northern California. And I traded the ocean and those fisheries for trout fisheries. So I was diving in mountain lakes to depths of 100 feet, looking at what was there, trying to figure out why the trout that were planted in those lakes didn't survive more than a couple of years. And coming to understand finally that it was the snow that covered those lakes to a depth of 20 or 25 feet. Every once in a while, which was every 2 or 3 years, and no light would penetrate. There was no food, no oxygen in those lakes, and the fish died. Right? And we were wondering why the streams kept stocking them with fingerling trout, little tiny trout, because it was a park. We didn't want to just put fish in for people to take out. We wanted the trout to play a role in the system, but as long as people were catching them and taking them out, we couldn't keep up with it. So we thought, well, we can stock them. So we put in fingerlings, but they didn't survive. And it turns out that many years before, somebody was trying to improve the stream, and they'd introduced eastern brook trout into these streams. And every time you threw in a bucket load of rainbow trout, the natives, the brook trout, ate them. Well, this is not rocket science, you know, we figured that out. But it was an exciting place. The other thing that I discovered was that if we're going to protect parks and leave them unimpaired for future generations' enjoyment, we need to do more than just guard the borders. We need to understand how they function. Otherwise, we're like a bunch of doctors trying to take care of patients, and we're going to treat high blood pressure by applying leeches or cutting open a vein and letting the blood out to reduce the volume. That reduces the pressure, no doubt about it. Boyle's Law tells you that. You've increased the volume, the pressure is going to go down, okay? We needed to understand to get to the root causes of stress in parks. So that sent me scrambling back to graduate school, and I was so excited that I could apply this ecology. Parks were the place, and when I finished graduate school, I contacted the National Park Service, said, you got any jobs for biologists? I was a recovering park ranger, and I thought maybe they'd have something for me. I was so excited about it, and I talked to the aquatic scientist for the Park Service in Washington, D.C., and he says, well, you know, we've already got 6 biologists in the Park Service. We don't think we need any more. We take care of people, right? We just guard the park. And I thought, oh, that is really disappointing. But the next day, I got a phone call from the regional office, the Park Service regional office in the Southeast, and they offered me a job as a campground ranger in the Virgin Islands. They wanted me to go to Cinnamon Bay on the north shore of St. John and live there and talk to people and guard the park and teach people how to snorkel and introduce them to coral reefs. So my job included going down to Trunk Bay every Tuesday and Thursday, meeting people largely from the East Coast, New York, New Jersey, that had rarely had 2 feet off the pavement at one time, and teach them how to snorkel and introduce them to coral reefs. It was a pretty exciting opportunity, in actual fact. It was a lot of fun, and I enjoyed it. And I learned a number of things. One was, well, what are we going to do with these people? How are we going to connect them to the reef so they cared enough about it to want to protect it? It was hard enough when you could see the grandeur of nature around you, but when it was underwater and you just barely got glimpses of it, how do you do that? And we said, well, maybe just like we do on land, we should create a trail, and we can point out the different kinds of corals and sea fans and lobsters and urchins and fishes hang out in these places. So we put in some trails underwater and marked them with little signs, and people would follow. People just absolutely love those. But we had a little problem that people could fish in the park as well, and they're dragging behind boats with motors on them, dragging hooks on lines. He said, we really need to separate the people and the hooks and the lines and the motors. So let's not fish around the underwater trail. So we established tiny little reserves, places where fishing was prohibited, mostly for safety reasons, around these trails. And we discovered in a very short period of time that the kinds and numbers and sizes and behaviors of the animals along the trail changed. Not having spear fishermen or people trying to grab the lobsters under the coral heads changed their behavior, and they became wonderful little aquaria, places where nature was reestablishing the normal dynamics of the system around these little reserves along the underwater trails. One of the other jobs that I had, in addition to the campground and the snorkeling and those kinds of things, was to haul VIPs around. When you're in the Virgin Islands and it's snowing in New York, anybody who's got any pull at all wants to go to the Virgin Islands. So you take folks around. And one day, I was given the task of taking this group of folks around, and they said, I was told they're from the Navy and from NASA, the space agency, and the Department of Interior Fisheries Department. And they're trying to put a man in the sea project together. Again, exploration of the ocean, being driven by security and commerce, had not changed in 500 years. That's what was driving this. Right? And they said they're looking for a place that will help the Navy protect the coast. Soviet submarines in the 1960s are cruising up and down our coast, just as ours are on their coast. But the Navy wants to build houses, outposts on the continental shelf. And other folks are interested in exploring space and other limits of human activity. And so I took these guys out and I showed them a number of places where I thought they could do this project. And they picked one of them. They were looking in the Bahamas and the Dry Tortugas in Florida, over at Puerto Rico and the Virgin Islands, and they came down and they picked one of the places. And there was a guy on the aquanaut team by the name of Scott Carpenter, who was an astronaut and an aquanaut. And for reasons that I don't know completely, he had to drop out of the project about 9 months before the dive, and they needed somebody to take his place, and I became an aquanaut on Project Tektite. Who knows what a tektite is? That was one of the little questions. All right, we got some good folks here, but there weren't very many hands that went up. A tektite is an object of unknown origin that comes out of space and falls in the ocean. Okay? So why did this project become Tektite? It was because it was designed to help NASA understand the design of space stations and the behavior of people who were isolated but challenged by their work. And it was going to be applied in the ocean. So it came from space, and it was going to be used in the ocean, and it was going to be built by the General Electric Company, and they had actually designed it as a space station, but they lost the plans and who designed it in the first place. It was on the shelf, literally. They pulled it off. So it was an unknown origin coming from space going into the ocean, and some clever person, probably a geologist, called it the Tektite project. So we were there exploring, and it was going on all over the world. Jacques Cousteau had done a series that he called Con Shelf, of living on the bottom of the ocean in the Mediterranean and the Red Sea, and they had been living on helium and oxygen as their mixture, because nitrogen is narcotic, the air that we have. At pressure, you know, it's, dentists use it as a, I've lost the word. Yes, nitrous oxide, but they use it as an anesthesia, right? Anesthetic. And that could cause some problems. And the other problem is that when you're breathing helium, you get that Donald Duck voice, which is really fun at a party for about 10 minutes, but living that way for a week or 2 or 10, and the French is really hard to understand. Oh, it's terrible, right? The other problem is that when you're breathing helium, because of its very low weight, you lose heat rapidly. And human exploration in the ocean is really very limited by our heat loss. We need to maintain our body temperatures or we're in trouble. And the helium is a problem, and it's expensive. Nitrogen, not so much, but we don't know anything about the biology, about the physiology of living that. So the aquanauts were really guinea pigs, right, for the hyperbaric medicine, for the space program, and for the Navy, figuring out how to live there. But for the fishery side, we were trying to understand, is this a better way to do research? If you dive from the surface, you can only spend about 2 hours a day, even with the repetitive diet tables and all that sort of stuff, about 2 hours a day doing research on the bottom, making observations and measurements. But if you live on the bottom of the ocean, there's no limit. You just have one decompression the day you go back to the surface. So if you stay down there, you can stay down a month, 2 months. So the Tektite mission was 60 days. Let's see how long we can do this and see how much we can learn about it. It was a really exciting time, and we learned a lot of things. But I'm going to move on, because that was just kind of the step that moved us in the right direction, to learn more about how the ocean functions. We finally had the tools and the technology to do that, and there are lots of stories that go with that. My next stop was actually to spend 2 years with the U.S. Army in a virology lab in Sausalito, California, playing volleyball up and down the West Coast. But as soon as I was done with that, my boss from the Virgin Islands had moved on to Everglades National Park, and he needed a marine biologist. Finally, the Park Service was beginning to recognize they needed biologists in parks. They were really handy to have around. And so he called me and said, I need a marine biologist, come help me out. So I spent the next 10 years in South Florida. And Everglades was a place where we learned a lot of lessons. And one of the things I wanted to point out to you that's related to where we live here around the Salish Sea is that South Florida is very similar in size and has a lot of shared characteristics with South Florida, believe it or not. About the size, about the number of species, about the number of things that are endangered, that have problems there. And there's a lot of competition for limited resources, not the least of which is fresh water. So Everglades was an interesting place. Fresh water is what drives the whole system. And there was competition. Farmers wanted to bring their products, primarily truck farming like tomatoes, to market when the New Jersey farms could no longer bring their product to market. In South Florida, you could grow things anytime. It's just a matter of propping up the plants. There's water and sunshine, and put a little nutrient on it, and you've got tomatoes, right? And so they needed to drain the fields at certain times of the year, and they needed to be able to plant and bring their products to market. They knew exactly how much water, where to put it, and what quality it had to be to make that work. The metropolitan users of water in South Florida knew exactly what they needed, which was an average amount. In South Florida, there's a wet season, which is all summer, from April until October, when it rains like mad and they occasionally have hurricanes, right? And then it doesn't rain again from October into April. So there's a dry season. Well, metropolitan users don't understand that they can't flush the toilets or drink anything for 6 months when it's dry. They want water all the time, so you need to dam it up, right? So you've always got some water, but before the flood comes and the hurricane, you need to be able to dump it out. So they engineered the whole South Florida ecosystem so that they could meet those needs. But the question was the relationship between people and nature, and what does nature need to continue providing the services that everybody relies on in South Florida? And the foundation of all the local fisheries come from the Everglades, come from the nutrients in that system for shrimp and crabs and lobsters, the sport fish that are caught there. So the question is, how do we sustain nature here? The wading birds, the alligators are all part of the system, along with the mosquitoes and the sawgrass and all the other bits and pieces. The wading birds come down there and form colonies for reproduction as the water is drawing down into the dry season. And it concentrates all the fish and the shrimp that have grown during the wet season out, and they're into a bouillabaisse, right? I mean, it's easy to catch what they need to feed their young near their colonies. And they decide where to build the colonies and when to build them based on water levels as they're drawing down. Alligators maintain the deep holes where these fish concentrate, because they dig them out. And they build their nests of rotting vegetation, lay their eggs in them, right? And they decide how high to build the nest and where to put them and when to start based on the rate of the water going down, right? So they can look months ahead and say, if the water's going down at that rate for the past 5 million years, it's always worked this way, right? Okay, so we're going to do that. Well, now we've got agriculture draining things, metropolitan water users, we're all trying to compete for the water, right? And we learned how we could go about doing that. We learned a lot of things about how the system works, but we could pile up all those reports, all that knowledge, all that information, and it was not going to change people's behavior. You needed to connect to people emotionally and deeply. They needed to have some personal experience and understand what's going on in this system. And that's when we discovered we need to engage people and connect them. So we started environmental education programs to get every 4th grader and every 6th grader in South Florida went to the national park as the culmination of a year's study in science and math and engineering and technology to understand what was going on and how they were connected. We just taught one topic, and that was connectivity. How they're connected to each other, to the environment, how the mosquitoes and the sawgrass and the alligators and the wading birds are all connected to each other, and what it takes. All right? And that led people to a much deeper understanding of what was going on, and those school children in the 1970s became city councilors, commissioners, county commissioners, mayor of Miami, state senators, governors, U.S. senators. And not too many years ago, in the late 1990s, they organized political movements to get $9 billion of federal money dedicated to rehabilitating the Florida Everglades and match that with state funds. So these investments in connecting people to nature is a long-term strategy, but can be very, very powerful when people understand what's at risk and what they can do about it. And that education leads to a development of ethics. People's relationship with nature has been evolving for some time. And just in the most recent times, you know, it wasn't that long ago that if you didn't beat nature back, it would eat you or your children. You know, in Pennsylvania, they used to have mountain lions. They called catamounts or panthers. You know what the University of Pennsylvania's mascot is called, right? The Nittany Lions. That's because there used to be mountain lions there. But the people who lived there killed them. Because if they didn't, when the kids were walking home from school, the lions ate their kids. Right? It wasn't that long ago that we had that relationship. So that was the first thing. We kind of got past that. When we got plenty of people and we got better technology, we moved on. And for some reason, the pendulum didn't swing. It just flipped to the other side. And the transcendentalists said, wait, people are not part of nature. We're completely separate from it. Get out of it. Right? It's transcendental. We're going to preserve everything. People say, that ain't going to work, folks, because we live here and we need food and shelter. And we got to work out a compromise on this. And early in the 20th century, we came to the idea that, boy, we really understand how this works, and we can improve on nature. We can re-engineer it. We can get more out of the system if we make some adjustments. And that was the foundation of fisheries science, of forestry. There are a lot of environmental sciences that began at that time with the idea that we're going to engineer our way out of some of the challenges that we have of dealing with nature. And as that has faltered, in the latter half of the 20th century, we've begun to arrive at a place where we understand a little more about how all of this works and what our role in it is. And a fellow by the name of Aldo Leopold came up with this idea of a land ethic that says we're all part of a community. And what we need to be doing is looking at the integrity of that community, the stability, resilience of that community, and its beauty. And when we do things that enhance integrity, stability, and beauty, we're doing the right kinds of things. As I said, it's not really rocket science. We're just headed in the right direction. The question is, do we have or can we develop an ocean ethic? This is an out of sight, out of mind, alien environment. It's really a challenge to get people engaged in ocean things because it's so hard to see it, to experience it. It always looks flat and blue or gray. Right? How could it be changing so much? So, I think that we need to adopt a strategy that was used in the late 19th century to convince the American public who lived mostly on the East Coast between Boston and Washington, D.C., that national parks in the far west, these grand landscapes in Yellowstone and Grand Canyon and Yosemite, were worth keeping. They were never going to get there. It was the same issue we have with the ocean. It was kind of beyond our reach, beyond our ken. And what really turned the corner for conservation at that time were artists out of the Hudson Valley School, landscape painters, Thomas Moran, Frederick Church, even Mr. Bierstadt, Albert. Right? He conjured up a lot of things on his own, but the idea was there are these grand landscapes and these wonderful landscapes that are worth preserving and protecting, and once in a lifetime, you might get out to actually experience it, and it's worth it. It's worth it. And I think that's where we need to go with the ocean. We need to use what we have that's available to us to connect people with that. And we need to better understand what it is we've got. How do we know what's normal? I talked about when I started fishing in the 50s, it was, oh yeah, it's warm water, it's supposed to be that way. And then it turned cold, right? How do we set an appropriate baseline? How do we understand what it is we're doing and what we're trying to sustain, what we're trying to rehabilitate? How do we get there? The Dry Tortugas is a wonderful little place. It's about 70 miles west of Key West, 90 miles north of Havana, Cuba. Right? It's right in the southeast corner of the Gulf of Mexico. All of the shipping that comes out of the Gulf of Mexico, out of the Mississippi River, up from the Caribbean around Cuba, all turns the corner right there and goes into the Western Atlantic. There are shipwrecks there that go back to the 1400s, 1500s, 1600s, right up to last week. You know, boats are trying to cheat on that corner a little bit, and they run into a coral reef. We've known about it for a very long time. And when I was there, I said, well, the first thing we need to know about this place is how do we measure the health of it? We need monitoring programs that tell us about that, and the foundation of that are maps. Right? It's just like the mapping that we do around here now, the Benthic Mapping. It was very crude at the time, but I was doing habitat maps in the mid-1970s. And in the process of doing that, while I was doing the map of where are the reefs and where's the grass, I discovered that I wasn't the first one to do that, which shouldn't have been a surprise. Alexander Agassiz, an oceanographer from New England, had mapped it in 1888. He'd gotten stuck in Key West waiting for a vessel to take him to the South Pacific for research. So he hired a little boat and he went out to the Tortugas for those 2 weeks and created this map that was incredibly accurate. He never even got in the water. He looked over the side with buckets, with glass bottom buckets, and threw lead lines with tallow on the bottom and picked up the sediments. And he made this wonderful map. So I was able now to look at almost 100 years of change, 88 years of change. I thought, wow, this is cool. I can begin to see how things are going. And boy, were they different. The distribution of the corals and the grasses and things in his time were in little tiny patches, all broken up. By the time I was there, I was able to dive on these sites, and I had aerial photographs of it, and I could see that there were big, wide swaths. He couldn't have missed them. I said, wow, this is a big change. We're going to have to understand this. And so I started in on that, produced the maps, make the comparisons. In 1976, finished the map. 1977, I went back out, and the whole place looked just like it did in 1888. So, what in the world happened? Well, on the 21st of January, 1977, it snowed in Miami. A cold air mass moved across North America, across the Gulf of Mexico, right? And it entrained a bunch of cold water in the northern Gulf of Mexico. And by the 1st of February, A couple of weeks later, this massive cold water moved across the coral reef at the Tortugas, and it killed 90% of the branching corals. They're like radiators with branches sticking up. Right? The massive head corals, the brain corals, the big star corals, they were okay because the cold water was only there for about 4 hours. Right? So it was the tortoise and the hare. The slow-growing, massive corals survived. The fast-growing, branching corals died. It reset the ecological clock for them to compete. So I watched 100 years of change unfold and then saw it all go away in 4 hours. And it's just now starting to come back. That gave me an entirely different appreciation of how much dynamic there was in something as stable as a coral reef. Really an interesting perspective on this thing. Something else that was changing was the number of people who arrived at this place. In the 1960s, if a couple hundred people a year made it out 70 miles from Key West, I mean, the fastest boat around was 10 knots. It would take 7 or 8 hours to get out there and the same to get back. You couldn't do it. It was a 2-day, 3-day trip. Tourists weren't going to do that. Even dyed-in-the-wool fishermen didn't want to do that. But by the 70s, there were about 1,000 people. Ooh, big change. And then now there are over 100,000 people a year because of the change in technology. These big, fast catamarans, you know, running 35, 40, 50 miles an hour out there and back, no problem. Float planes flying back and forth. Right? So things change, and our relationship then with these places changes. In the 1970s, the big question was, well, when the park was created in 1935, all the commercial fishing was stopped because there wasn't any. There was no commercial fishing. It was a national park. Let's protect from commercial operations. But recreational fishermen, they thought, well, they should have 2 lobsters a day just for dinner. Right? Okay. So there was a limit. But people were concerned if we go from a few hundred to thousands to 20,000 to 100,000, what's that affect even at 2 lobsters per day? So we tested that. We conducted a study, went on for 3 years. And what we discovered was in one season, at 2 lobsters per person each day, you take half of the population in an 8-month season, and it took 15 years to replace it. We said, nah, that's not sustainable. Do we go back and test 1 or have a lottery? No. The highest and best use of the lobsters in this area, we decided, was as a source of replenishment. These big lobsters produce 10 to 100 times more larvae than the little lobsters. So let's protect the big ones in this park, and they will support the fishery in the surrounding areas, okay? There was only one little hitch in that, and that is that the really big female lobsters didn't produce any eggs. We thought, well, what's that all about? But it was consistent with our approach to fisheries, which was take the big animals, leave the little rapidly growing youngsters, right? That was going to increase growth rates, more biomass coming into the system. That's what fishery science was going to do for us. We said, well, okay, that's consistent, but we're going to close these. These are going to be sources of replenishment, right? 25 years later, the big lobsters, the big females, started producing eggs. Wow. Turns out it took 25 years to grow enough large male lobsters that were larger than the female lobsters, and that's what's required for mating. The female lobsters are not all that excited about this exchange. Right? And so the males have to actually physically overpower them and lay a spermatophore down on top of the female. She carries that around, and when she extrudes her eggs, then she fertilizes the eggs at that time and carries them until she releases them as larvae into the water. Right? So it took 25 years to see the effect. We just didn't understand what was going on. But we did learn that the lobsters at the Tortugas there, where we had an adult reserve, were producing the larvae that floated around in the ocean, and they landed in the seagrass beds in Everglades National Park, in Biscayne National Park. In those seagrass beds, the shallow water, they settled, the juveniles grew up there for 2 or 3 years, and then they walked out through the keys onto the reef and back out to the Tortugas. So we began protecting the juvenile lobsters in those seagrass beds and in those other parks. We said, well, this is a pretty good model for sustaining fisheries, right? So let's do that for conch and groupers and snappers, and pretty soon we had 50 species of fish on the coral reefs. How in the world are we ever going to manage a system that has all these different kinds of reserves at different seasons and things? We said, this isn't working. We need something better than this. And it turns out that there was an example for us to look at that was protecting a whole ecosystem in Southern California, at the California Channel Islands. a little place called Anacapa Island. It was a national monument, and half of it was closed to fishing to restore it, to rehabilitate it. And I said, that works pretty well. Let's look at that system. So I got a chance to come home to California and see what was going on. And one of the first things I discovered when I got back and looked at the kelp forest and talked to all of my colleagues was that things were really different. Remember I told you we'd used to go out in the morning and we'd catch a little Pacific mackerel that we'd use to catch marlin and big game fish? And we reported the game fish we caught in the newspapers? Well, now, 15 years after I left, I came back and they were reporting how many mackerel they caught in the newspaper. So in 15 years, people were proud to report they caught the bait. Now, you know things are headed in the wrong direction when you're bragging about catching the bait. The same thing happened in the Florida Keys. Same thing happened. If you can see in that top picture in 1958, the size of the fish and the size of the people are about the same. In the middle, the fish have gotten smaller, and some would say the people have gotten bigger. And then in 2007, there's a lot of small fish on that board. And these are the fish that people are bragging about, bringing back and taking pictures of that are in the scrapbooks around the world. And this is not just in the Florida Keys, not just in California, it's all over the world. There are people now practicing a new science called historical ecology, finding these pictures, these kinds of things, and working them out. So, we're now in California. It is really the modern era, the 1980s, but we still don't have a good way to measure the health of the ocean. We need to have that if we're going to understand what's going on. And we had some good models, and we began developing those so that we could actually measure what was going on. As everybody knows in manufacturing and all kinds of business and accounting, if you can't measure it, you can't manage it. And we were trying to manage the health of the ocean without being able to measure it. So we started on that, and we had some good examples of things that we could do. One was the DDT contamination in Southern California waters was impacting California brown pelicans, peregrine falcons, bald eagles that are all eating in that food chain. And if we had been waiting for adult pelicans to die before we recognized it was a problem, it would have been too late to do anything. They lived for 30 years. Right? We needed to have an early warning system, and some biologists had been monitoring the reproductive efforts and success of these birds. And we could see that the eggshells were thinned by the DDT, and that we needed to ban DDT from the system. And we had some success with that. And it took 20 years, but they've started to recover, and they're doing really, really well now. Right? And we said that monitoring was really cost effective. It was better than having those species go extinct, and for us not to understand the consequences of that. Another real quick example of that is related to the land and the sea interface, it's really important to us, is that we also started monitoring the island foxes. These are little guys they're the largest mammals on these islands off the coast of Santa Barbara to San Diego. There are 8 islands out there. 5 of them are in a national park. They're the size of house cats. They eat insects and berries. And their populations began to crash from like 1,000 to 1,500 animals on each island down to 15 or 20, 40 on one of the big islands. Really in trouble. So how did this happen, and what do we do about it? How's it related to all the things around it? Well, we discovered the story started in the 1840s when ranchers introduced pigs to the islands and grazing animals, sheep and cattle and horses, and it reduced the height of the vegetation to very low levels, which dried the island out. Half the water that came into the water system. I told you, free water falling out of the sky? Not in Southern California, I'm sorry. They get half the water from fog that blows across the island. And when the vegetation's this high, catches a lot of fog and it drips into the ground. You take the vegetation down to grass that high, water blows across the island, dries it out. Streams don't run, springs don't go up. You can't support much life. Really tough going. So that changed. DDT introduced in the 1940s. We'd already talked about that. Eliminated bald eagles from the islands. They're just not there anymore. And golden eagles, a few years later, a long time later, actually wandered out there as their populations recovered on the mainland, and they discovered these piglets running around. All sorts of food. There's no shelter because the vegetation's gone. You know, it's just grass. Wow, this is nirvana, right? And so they started eating the piglets, but occasionally they'd run across a fox running around out there, and they ate the foxes. And it was the golden eagles that caused that problem, right? It was tied to the DDT in the marine food chain, right? So what do we do to fix that? Well, First of all, we got to protect the foxes from going away. So we need a captive rearing program for them. That protective custody is in order. Have to clean the DDT up. We've been working on that since the early 70s. Then we have to reduce the impact on the habitat, get that going. So we've got to get all the grazing animals off the island, let the vegetation recover. We've got to move the food for the golden eagles, so we've got to get rid of the pigs. Right? And then we've got to relocate the golden eagles. I mean, they're not at fault. They just wandered out there. So we live trapped them, which is quite a chore, and relocated them to Susanville. And then we said, okay, now we need bald eagles. And we kept coming up to British Columbia and to this part of the world, finding young birds that were clean, had no DDT in their system. We take them to Southern California, and within 2 or 3 years, when they start reproducing, they got so much DDT, still no good. So we keep working on it. You know, it's an iterative process. So finally, we got to the point that on the northern islands, the furthest away from where the DDT was dumped in California, bald eagles were clean again. And so we reestablished bald eagles that kept the golden eagles from coming back. And there was no food source anymore, and then it was safe to release the foxes. You can imagine all of the decisions along the way about how many foxes do we need for their genetic diversity, what's the best way to deal with the DDT, what are we going to do about all these animals, what's the best way to get rid of pigs, how do we measure that effectiveness? What we discovered along the way, which is not surprising looking back with our 2020 hindsight, science was the best, fastest, cheapest way for us to learn how to do all of these things and make these decisions. So we did that. We had the same kind of thing going on in the ocean, where fishing was removing the largest predators, the biggest grazers from the system that was altering the whole thing. And the kelp forest down there is what drives this system. It is a rainforest in the ocean. It is like a coral reef. There are 1,000 species of big plants and animals that you can see without a microscope that live in Southern California kelp forests. And they were being reduced down to 200. 80% of the kelp, the canopy of that kelp, was removed in the first 20 years of it being a national park and a national marine sanctuary. And it was because of the disruption caused by fishing, the disruption of the biological interactions that fishing had on all of these species. And so what we were left with was rocky reefs covered with sea urchins that were eating all the kelp that tried to get reestablished. And we could not sustain fisheries. Abalone eat kelp. Without the kelp, there wasn't enough for them. And we were removing all of the big abalone from the population, leaving the little ones. So we lost the capacity of those populations to replenish themselves. And what we saw was a classic pattern used by hunter-gatherers the world over, people and other animals, right, that are out hunting. You take the things that are biggest, most valuable to you first. When you run out, you move to something else. There are 5 species of abalone in California that supported fisheries. They are conveniently color-coded. There's a red abalone. They were the first ones to go. They're the biggest, easiest to find. Then pink abalone, right? When we ran out of reds, we went to the pinks. Then we went to the greens that are in shallow water. There's a little blip at the bottom of white. Those are white abalone in very deep water, the most tender, selling for $100 a piece as the fishery collapsed. And black abalone didn't show up very well, so I made them yellow. Okay? But we went through 5 species, one after another. Right? Well, what do you do? Clearly, we were running out of abalone. What do you do? Well, that fleet shifted to sea urchins. Developed a market in Asia, and this is dollars, not, amount taken. It was dollars, and they actually made more money on the urchins that they're collecting for 25 cents a piece than the $100 snails, the abalones that they were picking up. This is the strategy that we have seen over and over and over again in the ocean, is moving from one resource base to another. As we run out, we move into new territory like we did with whales, right? Or we move to new species. We move along. And in our lifetimes, we ran out of new places to go. We needed to find a new way to manage these things, not one species at a time, but accounting for all of their interactions with each other, right? So they could support each other and provide the integrity, the resilience, the stability of the system. And what we had discovered from those little areas around the underwater trails in the Virgin Islands to a small area of protection around Anacapa and Santa Barbara Islands, that protecting the whole thing restored a lot of the integrity and the resilience and the health of these systems. So he said, we need to try that in other ways. And after almost 10 years of negotiating and We negotiated 20% of the park set aside in fully protected marine reserves. Nobody was happy. You know, it was a great compromise. Everybody was fearful that they either weren't big enough to have any effect or they were too big and going to drive me out of business. 20% was a negotiated settlement, covered all of the habitats in the park, and we said, okay, let's give it a go. They were established in 2003. After 8 years, we now have more lobsters and fish in the reserves. They are bigger, and they're reproducing more. And not only that, but the annual take, the amount of fish and other products that are taken out of the ocean have gone up by 10%, even though we're only fishing in 80% of the area. Landings have gone up by 10%. And even more significant is that the value of those landings is up almost 90%, 89% up, because they're taking higher quality, higher priced products to the marketplace. You say, whoa, we shouldn't have been as afraid as we were. But everybody was worried about that. Everybody was worried about it. But we've learned some things, so we're kind of on the right track. So where do we go from here? Where do we go from here? What's it going to look like? Well, nobody has a crystal ball, but we can learn from our past. And we've learned a lot about the ocean and how it functions. And I think that we can use what we know to do a better job of moving forward, and that's what I'd like to wrap up with. One of the things that we learned is that taking care of places, not just species, works really well. We have to learn how big those places are, how we decide where they go, but place-based stewardship works in the ocean as well as it works on land, maybe even better. The problem is we're 100 years behind what we've learned on land. And Yellowstone National Park was established in 1872. The National Marine Sanctuaries Act was passed in 1972, if you went bookends for that idea. All right? So, but we can learn. We can learn, and now that we know that. The other thing that we know, understand much better now, is the powerful connection between the land and the sea. With the Fraser River running down here, the salmon going back and forth and supporting forests. We know a lot about land-sea interactions, but those are very important. They're critical. We're not just managing ocean, we're managing the coastal zone. It's the whole system that we have to understand. And we understand a lot more about the complexity of marine food webs, of how the biggest animals are related directly to the smallest animals, and how we're connected to this whole system, and the complexities of those things, how important forage fish are. There are a lot of things that we're just now learning about, but we know that. We didn't know that 50 years ago. We didn't know that 40 years ago. We're still faced with threats to the health of the ocean by invasive species, by the loss of habitats, both in the watersheds and underwater, by contamination and pollutants, and by overuse, by taking more out of the system than can be replaced. A real quick review of that. People are moving invasive species all over the world every day, from ballast water in big tankers to fish like these lionfish that are in the aquarium trade that are wonderful in the South Pacific where they have competitors and predators. But when they were moved to the Western Atlantic and the Caribbean, nobody had ever seen them before, and they are voracious feeders on other fish. They eat all of the young fish of all kinds. San Francisco Bay is one of the most heavily invaded places. From 1850s to the 1960s, if they saw one new species get established a year, it was pretty average. And now, 1 out of 3 of the species in the bay is from somewhere else. A whole different community, whole different dynamic. We have to understand the problems with that. Do I need to say much about habitat loss? We alter our environments for our benefits, but it makes big changes, and we need to understand that. I'm not saying we're going to change any of it. We have to understand the limitations that we place on the productivity of the ocean and its capacity to absorb the waste that we put into it. We need to come to the right balance in all of these places. We have huge problems with carbon dioxide in the atmosphere and its acidification of the ocean as it interfaces with that. Since the beginning of the Industrial Revolution, pH has gone up 30%. The acidification of the ocean has gone up 30%. Almost all of that, more than 90% of that, has happened in the last 60 years. The rate of that change, it's not the actual value that is of concern, it's the rate of that change is greater than anybody has recorded in the geologic history. In the last 21 million years, we've never seen a rate of change like that. So the capacity of the ocean to deal with those sorts of change are going to increase, and the conflicts are going to increase. And we have to learn how to deal with fishing. For a long time, the scientific community believed that you couldn't drive to extinction any animal that produces 10 million eggs a year. That fecundity will bail you out no matter what happens, in large part, because the marketplace will stop being profitable. When you get down to the last few individuals, you'll quit fishing for them and shift to something else, right? That's our strategy. You run out of something, you shift to something else. So that gives them a break, and they'll come right back again. The problem is the market itself drives the value up. You guys hear last week? One bluefin tuna sold in Japan in the Tokyo market for $1.76 million. That was a half-grown frozen fish. It was 500 pounds, a little under. They get to be 1,000 pounds. And it will provide 10,000 servings of sashimi. But as long as the market will pay $2 million for a single fish, you can't rely on the marketplace to regulate the take to sustain the output of the system. We have to intervene. We have to find other ways of dealing with that so that we can care for that. We're not the first ones to walk down this path. If you look in the middens of the people who have lived on the Channel Islands for the last 13,000 years, you will see that they took all of the big abalone, and as the levels of the midden go up, the shells get smaller. And they get down to 3 inches from 12 inches, and then the site goes inactive for 200 years. But when you're there for 10,000, you can keep coming back to that place because nobody else came when you left. We've lost the opportunity to do that. So people sustained their use on the land, if you will, by being able to let it rest. We are seeing some signs of hope, some opportunities around the world, in Australia, in New Zealand, in the Caribbean, in Florida, in the California reserves, that small places in the ocean, and some large places in the ocean, can effectively be rehabilitated and become productive again, and they are much more resilient, much more resistant to the big environmental changes that we see in the chemistry and the temperature of the ocean. So there's reason to believe that if we continue to act in a responsible way, we actually can improve the health of the ocean in local areas that will build to a larger global effort and buy us some time. That's really what we're doing, is trying to make as many areas locally more resistant, healthier, and while we deal with these much larger issues. And there are some things that we can do as individuals. If you eat only sustainable seafood, and there's a lot of it around, and there are a lot of places where you can get little cards, and you can get online. I have an app on my iPhone that tells me, you know, I can check this kind of seafood and say, yes, this is raised or taken in a way that is sustainable. If we make that decision as individuals, as families, as communities, we can make a difference locally and globally. And if we support the idea of protecting special places in our neighborhoods, not in the other guys, but in our backyards, we can make a difference here. People are showing us that all over the world. And sometimes it's easy to get overwhelmed when you're trying to fix something as big as the ocean that's broken. But I think it's important to remember Margaret Mead and what she said about small groups of people. And we have one of those small groups of people right here. It's called the SeaDoc Society. Trying to help people gather the information they need to make good decisions, to understand how the system functions, so we're not like those doctors treating hypertension with leeches. Right? We understand the causes of the stress. We understand the systems much better. We can do a better job. So a combination of better knowledge, of education, of sharing the information can bring communities together to begin to work on these huge problems, but we can address them locally. I'm really glad to be here with you. Thank you very much for your patience. I would be happy to try a couple of questions. I wandered too long. I was having such a good time with you. Yes, ma'am.
Thanks, Dr. Davis. It was enlightening, and I can see your heart's in your voice. Thanks for coming and talking. Recently, there was a letter in Orcas Issues that said that there was an attempt to remove our local resident orca species from endangered species list because supposedly they were the same as the roaming other Pacific orcas.
Right.
Have you heard anything about that?
I know a very little about that, but Joe Gatos knows an awful lot about that. And we could probably get him to give us better answers. But I would say the endangered species list is a really nice tool, but mostly because it raises awareness that there are problems. And it shows us, it's a measurement that says as we can move things off of that list because they're actually recovering, it's a good thing. But it gets really wrapped around the political axle of people trying to get something they want without really restoring the integrity, the stability, the health of the system. And these decisions about the various kinds of subpopulations and how far down that road we need to go and what is significant are real challenges for us to answer yet. But Joe, did you want to talk about that, or is that something we should do offline because it's late?
I can give you just a real briefing. So there is a petition out, and it's in the Federal Registry, and I can get you a copy of that if you want to see it. And they're challenging that. It's a group from California that's interested in doing that, and I think that scientifically speaking, they don't have a really strong case for that.
Yeah. Okay, thank you for that. Yes, sir.
I'm thinking about the old growth forests and how forestry or the people, the lumberjacks and so forth, kind of killed their own business, their own industry just by over harvesting. And the fishing industry maybe is doing the same sort of thing, but you point out that in the past 60 years there's been a lot of insight into how these systems are working. And I'm wondering, is the fishing industry going to repeat what the forestry industry did, or are they smarter about the overfishing, and is it?
That's a good question.
Is it going to be better?
Yeah, have we learned from forestry things that we can apply to make fishing more sustainable in the long term? And the answer is yes, we can, but we haven't learned a whole lot. People have been fishing for hundreds and hundreds and hundreds of years. And if you look around the Mediterranean and places where people have been the longest, no, they didn't learn a whole lot. The cedars of Lebanon are long gone, and so are the tuna in the Mediterranean. But we are learning. So we are making some progress. And I think that's worth noting and talking to people about and being positive about it. But it is a strategy that we have always used, and I think people will continue to do that for a time. I don't know that we're going to be able to change that behavior easily. However, commercial fishing is different than recreational fishing. Significantly different. If commercial fishermen don't get a return on their investment equal, they quit. They have to. They're like natural predators. If the predator can't catch something because there aren't enough of them left in the world, they move to something else, and the commercial fishermen shift to something else. Now, the something else may not even be fishing anymore. It might be painting houses, which is a really different lifestyle, and it's not nearly as interesting, challenging, or satisfactory. But they're going to have to shift to something. Recreational fishermen, on the other hand, can afford to catch the last fish because they're there for the experience. They're there because it's fun. They're there because they're with their family or their buddies, or they get bragging rights, right? And so they're out there, and so what if they spend $1,000 on fuel and catch one small fish? They're going to go back because it was a great experience. There's nothing wrong with that. The problem is the pressure it puts on fish populations. And the other problem is that the recreational folks, you know, in my hometown of 18 million people between Santa Barbara and San Diego, the population of Australia, right? They don't see each other all that often. And they figure, well, there's just a few of us. There's only 5 on my boat now. They don't see the 500,000 people out there every day that are catching fish. And collectively, they have huge impacts. But they see that guy with the seine out there, the big purse seine, right? Taking 6 tons every time he pulls the net in. They figure that's the problem. Those are political, emotional issues that we need to deal with. It's a communication issue, being able to talk to each other about what's really going on in the system. And I think that if we have those discussions, what we did when we were talking about marine reserves in California, you know, we just 3 weeks ago finished actually the last of a statewide network of marine reserves that sets aside areas. And there were thousands and thousands of people in hundreds and hundreds of public meetings up and down the state. that have extensive discussions to come to that. We're beginning to get to that point. So in that sense, yeah, we have learned. And we are learning, and it is getting better. But there's a lot of pressure for doing it faster, better, and cheaper. And that's why science, I think, is an essential part of it, and what SeaDoc is about, is bringing that science out so we can learn faster. That's a great question. We got time for one more?
What challenges do you see for the Salish Sea and those of us that live in the Northwest?
The biggest challenge I've seen over the last 10 years of working with SeaDoc is being able to get the right people in the room together to talk. The huge challenges of overcoming the social and cultural barriers of federal and state agencies, of public and private, of Canadian and U.S., of First Nations and tribes. We can't even get scientists across the border easily because the government regulations don't let them travel to foreign countries, right? And the same is true from the Canadian side. So we have meetings on the picnic benches at the Peace Arch, right? We've got to do better, folks. If we're going to emulate and compete with systems like South Florida and the Everglades, the Chesapeake Bay rehabilitation efforts, the San Francisco Bay estuaries, people have got to get together in the room and say, look, we have to work on this together. If we fix this part, if your part's still broken, we're not going anywhere. Those are all artificial, to nature artificial, very real to all of the people in our cultures. And for me, that's the biggest barrier to moving things forward. And it has to come from community groups and people willing to develop trust and partnerships across all those barriers. All right. Thank you very much.